What is the image of a set? To understand it, we start with the two key ingredients. First is the definitional function that we saw previously, and the second ingredient is a subset of the domain of that function. So let's see an example. Let's recall our labeling function, which assigns the elements of the set X, which consists in the set of fruits in your local supermarket, assigns to these elements the set Y of labels. We find here our set of favorite fruits, and since the labeling function maps each one of these elements into this, then we say that the entire set A is mapped into its image set, which we denote by f of A. Mathematically, our set f of A is defined as follows. So f of A is by definition the following set. The set whose elements are the labels y belonging to the codomain, big Y, but we don't want just any label, we want those labels for which exists a fruit in big X which is assigned to that label. Let's look more closely into the element U test for our set, because as it stands is neither true nor false. Once I specify a label y that makes it true, that is a y for which there exists a fruit attached to it, then that label y, well, it's approved, and so it enters in f of A. Now, with this definition in our hands, let's see some examples. The specific function we are going to use is a function s of x, which is by definition just 2 times x. And the set that we are going to consider is a set A, which is just contains 3 elements from -1, 0, and 1. Geometrically, this set essentially is centered at 0, 1 unit to the left, 1 unit to the right. So when I act with this function s, which note is a bijective function, this gives us what? Well, -2, 0, and 2. Now, what is the difference between A and S of A? Well, let's see. This one is centered at 0, so as this. But now the neighbor elements of 0, here is +1 or -1, here is twice of that, is 2 and -2. So essentially, a set centered at 0, +1, -1, now it's twice of that. So the set became into a wider set. Now, let's consider a second function, c of x. And c of x is x divided by 2. If I now act with c on A again, so we get c of A, which is the set, well, it's -1f, 0, and 1f. And so you can see now that previously the set is 0, 1 to the left, 1 to the right, okay? And now it becomes just half of it, okay? So the set was compressed. So you can see that by acting with functions on these sets, you can either stretch a set or contract a set.